Welcome to this session, this live session PT44, Explore the Digital Thread with Rockwell Automation and EPLAN. My name is Sean Mulheron. I am the product manager for EPLAN Pre-Planning, EPLAN Fluid, and EPLAN Electric P8. I've been with EPLAN for 27 years now, so quite a while. Worked as a software consultant, technical support, been doing trainees, and since 2013, I'm part of the product management team. So I will give you a bit of a journey into our solutions portfolio to get a better understanding of what is our product offering, as well as how do our products interact with Rockwell software solutions or Rockwell solutions and Rockwell products. And as we go through that journey, I will always kind of reference and make sure you understand where the connections are. So let's get started with our ecosystem of engineering companies. So when we look at a project or an automation project, you have multiple different companies typically that are involved in that process. So at the bottom, you have the end user operator that identifies, okay, I want a product, I want to build a product, I want to develop a product, and I need a machine or machine systems or manufacturing facility. And they start typically with defining what are the specifications needed for that particular plant. And sometimes they'll even say, okay, I work very well with Rockwell products together, so I'd like to specify also Rockwell right up front in the specification process. So the involvement of component manufacturers can be defined up front in the engineering process. Then they'll start a planning process, identifying what different functions are required in their manufacturing facility and how that product is going to be assembled or even put together. And they put a plan together, whether it's starting with the basic engineering or general layout assembly of the system to identify how that facility is going to work. Then they're going to talk to system integrators or OEMs that are going to actually build the systems, build the machines. And this is where we start with our EPLAN project. So you need a data repository to start capturing your information up front. And the EPLAN project can also contain template information. So if the end user operator has a specific layout for the controls design, that controls design layout and the specification and the templates can all be stored in the EPLAN project for the machine builder or OEM to simply use and follow. The OEM system integrator will then start detailing the engineering. So start with the basic kind of product power distribution layout, and also the detail engineering, identifying all the controls requirement for that machine. Then he's going to identify a panel builder, whether the panel build is done in-house or it's using an external panel builder. They're going to transfer that EPLAN project containing all the schematic information over to the panel builder so he can start building the panels. Using the data that is available in the schematics, he can leverage his design, create a 3D model of the panel. We call it the digital twin of the control panel, and he can leverage the data of the digital twin to generate his fabrication. Before that, he's going to source all of his components. That means order all his components, and of course, ordering the components from the data portal or even Rockwell, and making sure that the parts are coming into the engineering environment. Then he's going to build the panel, assemble all of the components, and deliver that panel back to the system integrator or OEM. And the system integrator is going to make sure that that panel fulfills the functionality required. It actually works with the machine, and eventually they're going to deliver that machine to the end user operator. Once that machine is on site, that machine is going to be running, and they need to be commissioning as well as operations, troubleshooting, maintenance. And all of that can then be uploaded into the cloud, and we can use the ePulse environment for managing that project in the cloud and giving access, easy access to the information from the project created by the various parties involved. So all of that gives you an idea of how the data can easily be transferred and communicated between end user operator, system integrator, panel builder, and component manufacturers such as Rockwell with all of their hardware components for controls automation. EPLAN provides a suite of different applications. And if we look at the engineering process, you have typical mechanical engineerings with their mechanical tools such as Autodesk Inventor, SolidWorks, CATIA, various NX, for example, various different types of software solutions to create the 3D model. Then EPLAN comes in with all of their solutions to design the control system. So everything in red are the software solutions to design the control system. On the right-hand side, you see software engineering, which is the software to program the PLC. So there we're talking about Rockwell Studio 5000, which has the architect or Logix designer to build your program and to write the code for your various different PLCs. We also interface with ERP PDM systems such as maybe PTC Windchill for PDM solutions or SAP for ERP solutions so that we can interface the data contained in our environment and make sure that that data comes across to other business solutions in the engineering process. And up top, you have our cloud solutions such as the data portal, which is the repository of parts. We have the eBuild and also the eView that I will look in detail in a second. And all of that is your EPLAN project. So the EPLAN project is really your data repository of your control system in a design environment. So let's take a look at the individual solutions. The first one is EPLAN pre-planning. EPLAN pre-planning allows you to capture data upfront. So this is where we were looking at the specification phase or the pre-planning phase or the pre-planning phase in regards to capturing information upfront. So if you're a company that works in process engineering, if you have the requirements to create P&IDs or process flow diagrams, you can use EPLAN pre-planning as a solution to capture the data upfront, lay out your components, and already start your P&ID design. The beauty of pre-planning is the fact that you can capture all of data in a structured environment. So instead of using Excel sheet for your instrumentation or your signal lists or various different Excel sheets to capture the information, you have it directly tied to the design. So when you create your PFD or your P&ID, you also have the structure defined and all of the data created. This data structure is also very similar to Plant PAX, a Rockwell solution to program all of your process controllers for process applications, whether it's batch control or various different process controls. So a data exchange would be possible in this environment where the information from EPLAN could be sent to PAX or vice versa. Information from PAX could also be read into EPLAN. So interface capabilities are available in that environment as well. EPLAN pre-planning in the process engineering allows a user to also generate the data sheets. So data contained in the instrumentation, such as minimum values, maximum values, what type of environment the process is going to take place, certain requirements, all of this can be captured in a data sheet, and these data sheets can be used as order forms for ordering the components from various different manufacturers such as Andreessen Hauser, which would be an Encompass partner of Rockwell in that aspect. We also can manage cables. So if you have cabling requirements and you need to capture cable information between various different sensors or instruments and the controllers right up front in the planning phase, you can do that as well using EPLAN pre-planning. And finally, pre-planning can also be used as a quoting tool. If I design a process flow diagram or process and instrumentation diagram, I can capture the values for planning, for design, for construction, also price information for each one of my objects. And I can create a report identifying what is my signal requirements, how long it is going to take me to plan my system, how long is it going to take me to build it, and also to how much it's going to cost. So you can really use this tool as a quote/estimate tool right up front in the engineering process. EPLAN pre-planning is also used in the building automation. So when you look at big buildings or any type of buildings, you have a lot of automation in there. Specifically, if you take a look at the HVAC aspect, the heating, ventilation, and air conditioning aspect, you control the flow of the air from outside the building into the building, and in the process, you have to heat the air, you have to cool the air, you have to add or remove moisture, you have to make sure the air is at the right temperature, and you have to push it through the building. These are all tasks of automation. So you'll have various different sensors, you'll have motors, you'll have fans, you'll have air conditioning, you'll have pumps, you'll have coolant, heaters, all of those types of devices that need to be controlled. And for those type of tasks, you'll create these similar to PNIDs, where you identify the flow of the hot and the cold air through your system going through various different process stages. Important is to capture the number of signals available and to make sure that these signals are all wired and controlled by your control system in the building. Here you also have overlays on top of existing architectural drawings. So you could import from Revit, for example, an overview of your building. And on top of that, you could start capturing all of your control system, whether it's for security system, alarm systems, your lighting system, your electrical control systems of that particular building could be done on top of an overlay that you would import into pre-planning. And of course, you have that structured approach where you can see your building according to how many floors it has, which floor it's on. In each floor, you could see the individual rooms. And then for each room, you could capture all of the sensors and actuators needed for that particular system. EPLAN pre-planning can also be used by OEM/system integrators. And in here, we look at systems layout. So here you have, for example, a conveyor systems, and each conveyor systems can capture various different controls equipment, such as motors, such as sensors, proximity sensors, light barriers. All of those types of control equipments can be associated with a graphical object. And these, of course, can be structured again, so you have a very quick ease of understanding of how your system is put together. And then at the end of the day, you can also generate quotes just like you did for the process environment. Pre-planning can be used for MCC and switchgear design. In those types of applications, what you focus on the elevation drawing. So the elevation drawing is looking at your segment, your section of your panel, and in each section you identify the buckets, and in each bucket you're going to specify the size of the drive and what type of controls you need for your particular application. So instead of using just your typical napkin or kind of sketch to be able to capture that information, start doing your elevation drawing directly in pre-planning, and of course you'll get a structured view of your different sections of your buckets, identify exactly what's in the buckets, and you can leverage that information to drive your control system. Then finally, pre-planning is also a data import tool. As I mentioned before, if you already have tools that do your PNID, like AutoCAD PNID or other various different CAD tools, or even if you have Bentley Intergraph or other types of process and instrumentation diagrams tools, well, you might have your PNID already laid out, but you haven't done your control system yet. So import the data from those tools through a data import interface. So any type of Excel sheet, instrumentation list, signal list, IO list can be imported directly into pre-planning, again, giving you a structured view on that system. And that structured view allows you to organize the data, add information, remove information, modify information, and help you to drive your controls design. So again, an easy way to import data into the platform to start your controls design. The benefit of this data import is you can import the same data multiple times. So if somebody made a modifications in the source file, such as the Excel file, then the information will be flagged as it comes into EPLAN. So you always have a clear overview and understanding of what data in the source has changed, what data was modified or needs to be imported, what stayed the same, and maybe also what data got deleted and needs to be removed from your design environment. So all of those are functions and features available using pre-planning as a data import tool. Then we have EPLAN Fluid. EPLAN Fluid is our solution to design fluid power applications. So whether you work in hydraulics, pneumatics, or cooling and lubrication systems, you can use the ISO 1219 standard symbol libraries to put together your control systems for your compressed air. So here we have an air preparation unit. Here we have a valve manifold control, and we work together with Encompass partners like Festo as well that can easily download the components from the Festo configurators or even from the data portal. You can easily place those components in here in your design environment, and you can use that information to also drive the design. Here we have an example of an hydraulic power unit. So if you are in hydraulics or you design hydraulic systems, you can easily capture your tanks, your pumps, and all of your hydraulic cylinders and the flow of the oil inside of your circuits to help you design your control system for your fluid power application, such as presses, heavy lifting equipment, platforms, and so on. Finally, you can use Fluid to also generate bill of materials. So with a click of a button, I can generate all of the parts that are associated to my design. So we don't keep the bill of materials separate from the design environment. They're all integrated into one environment. So if you're missing something in the bill of material, that's probably because it's also missing in the design. So it kind of makes sure that you are accurate in your design, make sure that you're not missing anything. So it kind of keeps track of the information in both environments, bill of materials as well as design. EPLAN Electric P8 is your electrical controls design system. This allows you to design anything electrical, from single line diagrams for power distribution, so you can easily capture your components here in a single line environment. You can also lay out all of your cables. So if you identify all of your cable trays around the machine, you identify where your sensors and your actuators are, then you can route the cables and do cable length calculation in 2D. So this is a field sys application to design or to lay out your cable topology, for example. Then we can do various types of schematics, whether it's North American style schematics, here organized in a ladder orientation with the North American symbology, or if we use the IEC symbology, which is a different orientation, different symbology, but all of the symbols are provided in the libraries directly out of the box. So EPLAN supports whatever design requirements you have today with your various different systems. And here we have a loop diagram example. So if you're in the process industry and you want to represent the wiring for a particular sensor or an instrument, you can easily design that with all of the information coming from pre-planning and allowing you to now wire all of those sensors through junction boxes, marshalling panels, DCS cabinets, and creating those loop diagrams. Here we have an example of interconnect diagrams. So if you have a harness application, for example, and you need to lay out how the harness plugs and pins are connected to each other, you can create interconnect diagrams that are going to be the starting point for your harness application. Again, generating bill of materials. So the schematic and the bill of materials are really one and the same. So while you do your schematics, you capture your bill of materials, and the click of a button then generates that bill of materials to always make sure that your schematics match your output. EPLAN Pro Panel is a 3D panel design solution, and that solution allows you to design your control cabinet in 3D. Well, when we talk about 3D, a lot of users are always afraid because, oh, that's a very heavy mechanical topic, and I need to learn how to create mechanical models, extrude, and such. Well, this is not a modeling package. This is simply a pick and place package. So the models are already existing, so you don't have to create them. All you do is you select a control cabinet, you identify a surface, and then you place the part in 3D onto a DIN rail, on the back plate, on the door, on the roof, on the side, so you organize your panel just the way you need to. So it's a very simplified 3D design tool, so that way even an electrical design engineer doesn't need to learn a complex mechanical package to start laying out his control cabinet. But the fact that the control cabinet is in 3D gives the user now a huge benefit and added value to make sure that everything fits, that everything is organized correctly. So whether you have control panels, marshalling panels, DCS panels, or power distribution panels with copper bus bars, you can easily lay out your systems in 3D and then generate the respective manufacturing documentation. Here you have a flattened view of your bus bar, for example, identifying where the holes need to be drilled in a specific bus bar. If you have a bending area where the bus bar needs to be bent, you'll have an identification, and it kind of shows you how to manufacture that particular bus bar. Here we have the wiring inside the cabinet. So if you have a schematics, you have the source and the target of your wire, you have a 3D control cabinet, you know where those components are, and the system can route each wire automatically through cable ducts or wireways inside of your control cabinet to generate the wire list. Here we've got an example of a pneumatic cabinets. So here you've got a valve manifold, you've got your tubes, you've got your air preparation unit. So everything is contained within a control cabinet, and the documentation and manufacturing documentation can be generated from that 3D model. So whether it's an electrical cabinet or pneumatic cabinet, you can easily design those in 3D. Here's that hydraulic power unit that can also be represented in 3D. And here you have the topic of piping. So these pipes can easily be laid out in 3D, can be organized. You can change the bending radius, the bending position. You can change the length and the routing of those pipes. So you can create a data for manufacturing those pipes easily after the fact. Here is the manufacturing documentation that's auto-generated from the 3D model. So once you have the 3D model in place, all you do is click on a button and these different views can be generated automatically. So the 2D backplate, the door, all of the holes, all of the dimensions can be laid out automatically by the system. So the user really doesn't have to spend time creating the different views or the different types of information. He just clicks a button and the system takes care of that for him. So it's a really neat functionality. EPLAN harness allows you to do the cabling within a product. So the harness is within a device, within a component, within a product, within a vehicle, for example. Here we have just a vehicle, and if we look at the vehicle from a harness perspective, we are identifying all of the network of cables and wires that are inside of the car. So we need to know the 3D model on one side. How does the 3D model look like? And once we have the 3D model, then we can identify the paths and the routes that these wires can go along to be able to go from the actuators or the sensors on the car all the way back to the board computer to make sure that everything is connected correctly. Then the harness can be extracted from the 3D view and laid out in the 2D view for manufacturing, because at the end of the day, you need to manufacture that harness. So here we have a flattened view of a harness, and then we need to identify the nail board drawings to manufacture that harness. So the nail board drawings would be auto-generated from harness based on the 3D model that you've laid out your harness and wires and routes in 3D. So here's an example of a product, and then you can see the various different paths and the harness information associated to the control system. So that can all be laid out in harness, and it can help you generate the manufacturing documentation for your harness a lot easier. Here's also a view for field cabling. So if you go from a machine, from the control cabinet all the way to your actuators that are on the machine, all the field devices, then you can also identify the routes around the machine that it can take, and the system can route the cables based on the schematic drawings that are available. Here's the view of the manufacturing documentation. So there's that nail board view in 2D. This was auto-generated by harness based on the 3D model. Then we have the data portal. So the data portal is a repository of parts. So we have over 950,000 components from over 300 different component manufacturers available online. And part of those manufacturers is Rockwell, and Rockwell has over 30,000 components available to download. So if you're looking for a variable frequency drive from Rockwell, you don't have to start looking for the DWGs and PDFs and everything else. You just simply go to the data portal, look up the part number, download that component, and it's already available for you to place it in the schematics and wire it up to the rest of the system. So whether you have VFDs, push buttons, protection devices, PLCs, all of your PLC components are available for download right there and then. So it really makes it easy for the engineer to simply click on a part, download the part into the platform, use it for your engineering design, and then afterwards click on a button to generate the bill of materials and order that part through your Rockwell partners. Here's an interface showing what the data portal looks like. So when you select the part, you've got pictures of that part, and you can see whether that part has a 3D model for Pro Panel, if you have a 2D view for the schematics, or a 2D view for the 2D panel layout. So various different information is available for those parts. And again, clicking on a button will download that part locally in EPLAN and allow you to easily use it, whether it's in Fluid, whether it's in Electric P8, or whether it's in Pro Panel, directly from the data portal. Then we're looking at the production area. How do we get the information from the design environment onto the floor, the shop floor, so they can manufacture the panel? Well, we want to transfer that data as seamlessly as possible. So we have various different interfaces to production machinery. So you know these CNC machines that can lock in a backplate, and you can simply just auto drill all of the backplate, like a Steinhauer machine or even a Perforex machine. Those types of tools can be driven directly with the data from EPLAN. And this data can then be extracted from the platform and sent directly to those machines. Also, for the wiring, you can export all the wiring information from EPLAN. You can send it to a wire terminal or Comax machine to automatically pull the wires to length, cut them to length, crimp them, label them, and make them available for wiring. And using a tool here like the smart wiring, instead of wiring using your schematics, which is the traditional way of wiring a panel today, you can wire your schematics off of a list. The list will tell you the source of the wire, the target of the wire, the type of wire, the color, the gauge, the label, and the end ferrules that I used at the wire. And you can easily pull the wire from that wire fabrication machine and just simply wire them up in the control cabinet. So it's a tool to simplify the approach of wiring inside of the cabinet, since the wiring is one of the tasks that is the longest inside of your panel build aspect. So various different tools and systems can be used to make your panel building a lot more efficient if they are driven from the data that comes directly from your engineering tools. Then we have the PLC DCS interface, so programming data exchange. If you have done your schematics, then you know what type of sensors you have and how these sensors are wired to your PLC. So one, you need to do a PLC layout, a hardware layout of your system. That can be done in Studio 5000, in Architect, or even in IAB. This information can be sent to EPLAN to have a general idea of what hardware is needed. EPLAN can do the interconnection between the PLC and the sensors. And now you need that information again back in Studio 5000 and Logix Designer to be able to write the code for the PLC. So we provide bidirectional interfaces between Studio 5000 and EPLAN Electric P8 using Automation ML. Automation ML is like an XML interface specifically for I/O information as well as additional data that can be stored in there. But primarily right now it's for the I/O information, and you can exchange your hardware data, your tags, your descriptors, your topology can be exchanged between EPLAN and Studio 5000. So that way there is no more need for manual takeoff of the data from the controls design into the software programming. So it makes the transfer of data a lot more seamless, easier, and error-free. Then we have ERP, PDM, PLM integration. So in that case, we can interface with PTC Windchill, for example, or even Autodesk Vault or SAP for your ERP system. So data that is needed in those systems can be transferred from EPLAN to those systems, or if you already have data in those systems, we can bring them directly into EPLAN and leverage that. So instead of re-entering the data, you can simply transfer the data between the various different business systems available. And the cloud application EPALS allows you to upload data in the cloud and provide you with an environment where you can easily visualize the data, you can collaborate, you can access from anywhere, any system. All you need is a browser, you can view the project, and then if you have your machine running, you can also use it for troubleshooting. So you don't have to carry paper or containers of or boxes of paper with you around. You can simply have a tablet, log into the website, access your project, and visualize the control system for troubleshooting, maintenance, and installation if needed. So we're based off of the Azure cloud, and that provides you an environment where you can store your controls information. Additionally, a topic like eBuild can also be available online for generating your designs. So some libraries are free to download and to use that can allow you to quickly create your engineering documentation as well. And then finally, the EEC, which is the EPLAN Engineering or EPLAN Engineering Configuration, allows you to take a modular library of circuits, plug that into a configurator, and through the EEC generate various different configurations. Once the configuration is created, then it can generate the documentation associated in various different systems, whether it's the quote for that system, the bill of materials, the 3D model, the schematics, the PLC software, or even the manufacturing data for your manufacturing of the control cabinets. So it's a highly efficient and automated tool to help you automate the automation design, in a sense, and make you even more efficient in your engineering steps. So that kind of wraps up our different solutions portfolio. And now I'd like to dive into just a software presentation just to give you an idea of what the tool looks like and how the tool can be used to leverage information in EPLAN as well as in the different Rockwell applications. So I'm going to share my screen. And now we're going to go into EPLAN Electric P8. So in this environment, I'm going to start with EPLAN pre-planning. So EPLAN pre-planning allows me to graphically capture a control system. So here I've got a couple of conveyor systems. I'm going to take a conveyor. I'm going to simply drop it in here. I'm going to drop another one right next to it. And then I'm going to put a turntable. So this turntable is going to be used for processing my components. Then along this conveyor system, I'm going to place a couple of robots. So I'm going to select this robot using my tab key, which is typical EPLAN functionality. I can rotate my symbols. I'm going to drop one robot here. I'm going to drop another robot here. I'm going to put two more, or I'm just going to put one more robot here in this corner. And I'm just going to drop one more down here. So you can have different variations. So up to 26 different variants are available per macro. Then to control all of these robots and the power to the conveyor systems, I'm going to add a control cabinet. So I'm going to select a control cabinet. Again, using the tab key, I can have different types of cabinets. I'm going to drop it in here, and I can start my layout. So this is a very basic start. And now at the same time as I've done this graphical layout, you can see that my system has conveyor system 2, conveyor system 3, it has my turntable. And the more I drill down, if I look at my conveyor system 2, now I've got a cylinder, which is the cylinder that actuates these two clamps. I've got a sensor at the beginning of the conveyor. I've got a sensor, a light barrier at the end. I've got the motor that makes the conveyor system run. And I've got my robot right here. And so if I look at the individual objects, I look at my cylinder, for example, I can capture various different types of data. And this data can be information for my planning. So I can have how long is it going to take to build that system? How long is it going to take to plan that system? How much is it going to cost? So right up front, I can now click on a button and generate a report. So if I just go to this report, utilities report update, so I'll have an updated report giving me the exact cost of my system. So here you can see how long it's going to take to plan that system, to build it, to program it. Here I've got the I/O information associated. So I know I've got 8 digital inputs or digital outputs, 26 digital inputs for a total of $84,000 in this case as an example for my system. So a very nice tool to early on capture a lot of information and give you a lot of data for you to process. Behind each object, I can also store additional information such as what is the signal requirement for each object. So if I have a motor, in this case I got one output and I've got 3 inputs. Or if I've got a cylinder, I might have one output, 2 inputs. If I've got a sensor, I'll just have 1 input, for example. So as I create my control system, I can also automatically capture my signals. And this information then can be used to size my PLC configuration if needed. So now let's take a look at my hydraulic system. So I've got these 2 cylinders or these 2 clamps that I need to design. So now I can take the cylinder, and if I look at the cylinder in a bit more detail, we also can store the macro information. So the macro information is what is this cylinder going to look like from a circuit perspective. And here we can see the specific layout of that cylinder, whether it's from a circuit diagram perspective or from a hydraulic perspective. So now that I've associated this, all I need to do is drag this cylinder onto my page, and there's my tank, there's my pump, and there are my 2 cylinder clamps closing that particular system together. Then I'm going to go to my second conveyor system. Here's my second clamp, so I can just drop it in. So whether each one has its own individual hydraulic power unit or separate power units or combined, you can organize your designs however you want. Then if we look at, again, the machine layout, one of the topics that's interesting is the ability to organize your proximity blocks to connect your sensors. So I can insert here an additional macro. I'm going to find my sensor block. I'm going to drop a sensor block right here. And this sensor block now that is created here, I can say, okay, which sensors are going to be connected to it? So I can select these two like sensors, this one as well. I can simply copy them. And on my prox block, I'm going to insert the link. And now the system has linked these 4 sensors to that particular prox block. So you can organize exactly how your sensors are tied to each individual device. Here you can also, if you need to, for a prox block or motor or a sensor, you could also associate parts. And these parts, they can be selected from a parts database, or you can even go to the data portal, and the data portal then provides you access to your Rockwell components. So if I go here to the data portal, open that up, and here you would see Allen Bradley. You could look at the data that you need for your system. Here you've got your Allen Bradley catalog, and you can easily navigate that catalog and make those different components or circuits available and select them directly into your design environment. Yeah, so all of the 1756 family, 1734s, all of your types of components can then be from here through drag and drop automatically selected and placed into your design environment. So that's the data portal with the Allen Bradley components. So now I'm going to start laying out my circuit diagram. So let's go to the control panel. So in the control panel, by placing that, I already have a main protection device and also maybe my 24-volt DC power supply. So I can select here my enclosure. I can look at the circuit diagram that's being used. Here's my power feed, so I can select a different one. Here's my NFPA power supply. Right here, hit OK and insert that into my drawing. So through drag and drop, I can easily place that particular circuit into my drawing. So now you can see on this page, I got my main disconnect, and I've also got a 24-volt power supply. But I like to define for my robots what is the power supply to the robots. So I take robot 1 here from my different conveyor systems and also the one from the turntable. So I can select multiple at once. So I've got 2, 1, 2, 3, and 4. Just drag them on here. And now you'll have your circuit diagram here for your robots. So here's one robot. And as I go down, it'll offer me the other ones. And I can just simply place them and easily lay out the power distribution for each one of my robots that I designed. So you can see that the information created through this overview helps you to leverage then your design down the line pretty efficiently. Here's my motor starters. So if I look at this particular motor starter, let's just switch over. I'm going to copy or create a new page here for my motor starters. And now I can take this motor here, just drag and drop, and now I've got my control circuit for that particular motor for my first conveyor, and here's that motor circuit for my second conveyor. So it's as easy as drag and drop. So once you've got your objects, creating then the schematics associated to the control system is pretty quick. Let's take a look now at the control system, at the I/O specifically. As you can see, I've isolated each individual bit because I made it kind of generic. I said this is just a digital input. And you can see the connection point is 1, 1, 1, 1. I would like to use a Rockwell configuration. So for that, I'm going to switch over to Studio 5000 Architect. And in Studio 5000 Architect, I'm going to create a basic system. So I'm going to look at a chassis that I need. So I'm going to use a 1756 A4. Then just call it chassis. Then I'm going to use a standard controller, the L74. I'm just going to drop it here in my first slot. Then I'm going to use a communication device. It's going to be just an Ethernet communication device. And then I'm going to place an digital input module and a digital output module. So here we've got a 1756 IB16. And I'm going to place a 1756 OB16I for my particular application here. And using the functionality of Architect, I'm just going to simply map these blocks to the controller. So now they know who are they controlled by. And I'll do the same thing for my output card. And once I've done that, so I'm using the Rockwell proprietary system, and Rockwell knows which controllers fit to which, so I would get error messages if I'm not using the right hardware, or it actually probably wouldn't allow me to put these systems together. So I'm using the Rockwell intelligence to create my configuration. Now what I'd like to do is I'd like to export this information so I can use it in EPLAN. So let's go ahead and export my configuration here. So I'm going to select here RA config. I'm just going to delete that one and recreate it. And now inside of EPLAN, I can go ahead and look at that particular configuration. So I'm just going to delete, oops, now I've got my stuff here. I'm going to view my rack-oriented configuration. I've already got one in here, so I'm going to delete this. So I'm going to go and import. So under PLC, I can import the data, and I'm going to import this AML configuration file that I created, this RA config, which has that chassis with the 4 slots, confirm with OK, and now it's going to create that configuration in EPLAN. So it imported 5 devices, which is the chassis and the 4 components, 1 CPU, and 1 bus port for my communication. So here it is. I've got my station, I've got my PLC, I've got my chassis, got my controller, my communication device, and here are my PLC I/O modules. So let's go over to an overview. On an overview page, I'm just going to clean this up, and now I can just take my PLC I/O, and this is this one here, just drag it onto here, and this would showcase the I/O module, which has not been wired yet. So this is my IB16, and I can just drag my OB16 as well, and I can lay it out here. So this is an overview of that PLC card, showing me which I/O points have been used or which ones have not been used yet and are available for use. Now that I've got my cards imported from the configuration, I'd like to map these I/O points from my card to the I/O points available in my design. So this is these I/O points. So I can do it different ways. I can either highlight them here in the drawing, or I can select them in this navigator view. So I'm going to change the view to look at all my I/Os. I'm going to filter by inputs, so digital inputs, and then I'm going to select these 2 cards, or these 2 inputs, and I'm going to go to assign my PLC use in my connection block wire. So here I select the card I want to map them to. In this case, this is going to be my PLC input. And on the left-hand side, I've got the I/Os from the drawing, and I've got the I/Os that are on the card, and then I'm mapping them one-to-one. So now that I've done that, look what happens. Suddenly in the drawing, I've got input 1, input 2, or input 0, input 1, input 2, input 3. I've got the screw number that was transferred. I know which rack, which slot, and also the tag associated to it was created. So if I look now at my overview, and my overview page now suddenly shows exactly how my I/O has been assigned. So a very quick and easy assignment of the I/O from the design onto the hardware. And I can do the same thing for my motor starters from an output perspective. So I can highlight these 4 outputs, for example. So as I said, do it from the drawing or from the navigator. And in my PLC, I can do again, use PLC connection point blockwise. I'm going to select my output card. This is my input card. I'm going to select the output one. It's right here. So 1, 2, 3, and 4. These are the 4 outputs. Map them, confirm with OK. And now again, the information was transferred. I know exactly which slot, which rack, and which connection point they're wired to. And again, in the overview, it's updated. So a very easy way for the users to capture information up front in pre-planning and map everything into detail engineering and assign everything into the I/O. Now what I'd like to do is I'd like to go into my 3D environment. So if I look at my 3D layout space navigator, and I have an empty space here, so double click in here, I can insert a control cabinet. So for that, we are going to open up our 3D mounting layout navigator. And the mounting layout navigator here, I'll have a cabinet. So I'll have a control cabinet, and I can just simply drag and drop that cabinet into my drawing. So via drag and drop, there's my control cabinet. And then once I have my control cabinet, I can identify the various different surfaces. So I can say I want my mounting panel. Then I want to view the front of the panel. So I can just look at this. And now I can insert some wire ducts. I can insert some DIN rails. So in this case, I'm going to select the part number for my cable duct. And I can just easily lay it down here. You can lay it down here. Lay it down here, for example. And then I can place some DIN rails. So I'm going to select a mounting rail. Again, using part numbers will identify the size. So now I can say I'd like this DIN rail to be the same size as this DIN rail here. And I want to place it centered between these 2 DIN rails. So it automatically now centers it and adopts the length of that particular wire duct. So it's easy to kind of lay out your components. So again, here I can move this if I wanted to a bit closer. Now to place my components on the back plate, I can select here, for example, my protection devices. Here I've got my motor overloads, 2 of them. I'm just going to use drag and drop to place them on here. I've got my main disconnect that's right here, so I can just drop it in here. I've got my contactors, just drag my contactors here. I'm just going to place them 2 at a time. And then I've got my terminal strips. So here's my terminal strips that I can just drag and drop and place on this bottom rail. So as you can see, placing those components can go pretty quickly. And as you can also see, it's a 3D view of those components. So even if you don't have the 3D model of that particular device, it creates a block with the X, Y, and Z size, and it shows you the place that is needed for that particular component. And then now, because I've done my layout, I can view the drilling information. So this would be the drilling view, showing me exactly on the wire duct where the holes will be drilled. That's based on the placement of my components. And also, if I now route my wires, I can highlight my control cabinet, and I can go ahead and do a routing of my wires. So based on the schematics, the wires are now routed through the wire ducts, and I've got wire length calculations. So I know now exactly how long I need those wires to be and how do I cut them. So this is all information that can be generated pretty quickly and easily based on the design using EPLAN tools. And this information then can be exported to manufacturing systems for ease of or for improving your manufacturing capabilities. So that kind of wraps up the presentation. And on this note, again, just to give you an idea of what the EPLAN tools are, how they work, and also how they interact with the Rockwell components, whether it's the hardware components that you need to order and you need to drag and drop them from the data portal into the EPLAN software, or whether it's exchanging data from EPLAN into the I/O environment through Automation ML. Simplifying the engineering process is everything that we are all about. So again, thank you very much for attending this presentation. And if you have any questions regarding any one of our tools or software solutions, please don't hesitate to contact us. Thank you very much and have a nice day.